All right, let's dive into the fascinating and, let's be honest, kind of chaotic world of AI-generated art. It's incredible, right? You can get these amazing images from just a few words. But this new frontier is forcing us to ask some really deep questions. Questions about creativity, ownership, and what it even means to be an artist. So let's unmask the machine. So right off the bat, this is the big one. This is the central question that kicks everything off. And it might sound all philosophical, but believe me, it has massive legal and financial consequences. Can a machine, just an algorithm, really create something original? Or is it just a super sophisticated tool, like a fancy pencil? Well, the answer, it really depends on who you ask, and it turns out, where you live. Before we get into the cool tech, the nuts and bolts of how this stuff is made, we have to start with the law. Because right now, there is a high-stakes legal drama unfolding, and the decisions being made are going to shape the creative world for decades to come. And this table really highlights a major split in how people are thinking about this. Over in the United States, the law is pretty firm. You need a human author. Period. In a huge case, Thaler versus Perlmutter, a court flat out ruled that AI-generated art can't be copyrighted because, well, a machine can't hold rights. But then you just hop over the border to Canada, and it's a completely different story. In the Sirius painting case, an AI was actually allowed to be a co-author. That shows a much more flexible way of looking at things. So what this all boils down to in the US is this idea of a minimum creative spark. The law basically says that the real original idea has to come from a person. This point got hammered home with the case of a comic book called Zarya of the Dawn. The creator actually got a copyright for it at first, but then it was revoked. Why? Because it came out that the images were AI generated, and the court decided that crucial human spark just wasn't there. Okay, so we've seen the legal battlefield, but how is this art actually made? I mean, what is really happening inside that black box when you type in a wild prompt like an astronaut riding a horse on the moon? It pretty much all comes down to two key technologies. First up, we've got something called GANs, which stands for Generative Adversarial Networks. The absolute best way to picture this is as a game between two AIs. You've got one, the generator, who is basically an art forger. It tries to create a realistic image out of nothing but random noise. Then you have the discriminator, who acts like an art detective trying to tell if the image is a fake or if it's a real one from its training data. They just go back and forth millions of times, and both of them get smarter and smarter, until the forger is so good that the detective can't even tell the difference anymore. Now, the other big method is called diffusion, and this one works in a completely different way. Imagine taking a perfect, crystal clear photo and slowly adding digital noise, little by little, until it's just a screen of static. That's step one. The AI then learns how to do that entire process, but in reverse. It starts with pure random noise, and kind of like a sculptor chipping away at a block of marble, it carefully removes that noise step by step to reveal a brand new, totally coherent image. So, the big question, which one's better? Well, there's no easy answer. It's really all about trade-offs. GANs are like the sprinters. They're way faster at generating images. But diffusion models, even though they're more computationally intensive, tend to give you a greater variety of images and are more stable. You can think of them as just different tools for different jobs. This brings us to another huge challenge. Let's say you have two different AI models. How do you objectively prove that one creates better art than the other? For years, researchers have been trying to answer that question with, you guessed it, a bunch of math. For the longest time, the go-to metric was something called the Fréchet Inception Distance, or FID for short. To put it simply, it measures how similar the stats of the AI's images are to a set of real images. The whole idea was that a lower FID score meant the generated images were more realistic and therefore better. But there was a huge problem. Researchers started noticing something really weird. Sometimes, a model with a better FID score, a lower one, was actually producing images that, to a human, just looked worse. The math was saying one thing, but our own eyes were telling us something completely different. And this chart just shows the problem perfectly. You've got two models in a head-to-head test. Model B has the better, lower FID score. So according to the old math, it's the winner. But then you show the images to actual people, and the story completely flips. A staggering 92.5% of people preferred the images from Model A. The metric wasn't just a little off, it was flat out wrong. So obviously, that led to the hunt for new, better metrics. And one of the most promising ones right now is called CMMD. Now, I'm not going to get into the super complex math behind it, but the key thing to know is that it's designed from the ground up to align much, much more closely with what we humans actually think looks good. And what do you know? In that same test, CMMD correctly picked Model A, the one humans loved, as the winner. Okay, enough with the theory. How does all this actually play out in the real world? Let's take a look at the top open source models you can go out and use today, and let's break down what they're good at and what they're not so good at. Right now, two of the biggest names you're going to hear are FLUX1 and Stable Diffusion 3.5. Think of it like this. If what you want is pure photorealism, and you need an AI that follows your text prompts with incredible, almost scary accuracy, FLUX1 is probably your best bet. But if you need more versatility, especially for things like cartoons or more animated styles, Stable Diffusion 3.5 is a fantastic all-rounder with a massive community and ecosystem built around it. But, and this is a big but, no model is perfect. Flux.1 might be a photorealism champion, but it has a very well-known Achilles heel. The people it generates can sometimes look off. As one reviewer perfectly put it, they can look like they are made of wax or like life-size dolls. It's this really strange, unsettling quirk in what is otherwise an incredibly powerful model. Now, for a quick reality check, because this is something that trips up a lot of people who are new to this. You see all these stunning, super high-resolution AI images online, and you probably assume the models are just spitting them out like that. Well, they're not. No AI model right now can generate a 4K image straight out of the box, without some serious errors or weird artifacts. So, how is it done? It's actually a pretty simple two-step process that all the pros use. First, you generate the image at a standard resolution, something like 1024 by 1024 pixels. Then, you take that first image and you run it through a completely separate specialized AI tool called an upscaler, which intelligently increases the resolution to 4K or even higher. So, after all that, where does this leave us? We've gone from the courtroom all the way down into the code itself, and we've seen the very tools that artists are using this very second. This technology is moving at an absolutely breakneck pace, and it's forcing us to rethink, well, pretty much everything. And that brings us right back around to our first question. But now it has a new twist. Maybe the question isn't, can a computer be an artist anymore? Maybe the real question we should be asking ourselves is this. When the tool becomes so advanced that it feels less like a paintbrush and more like a collaborator, who exactly is the artist? Something to chew on. Thanks for tuning in.